happy last semester for the majority of people in the room. Yeah. Okay. So, in terms of how Algebra 3 works, because it's primarily a senior-based class, we got to be done with all of the stuff by the time that seniors are done, which they never say that actual date of when your last day technically is until later on, but usually it's, like the Friday before you would graduate. So if you're graduating on the 24th of May, the 24th of May, okay? So if you're graduating on the 24th of May, that means that we have to be done with all of our stuff by the 19th of May. Okay? Right? Which means all of the things that are going to be on second semester final need to be done by then. Okay? And there's some stuff. Now, like we did 4 units in first semester, we'll probably end up doing 4 units in the second semester also. This first one is a shorter unit. So unit 5 is going to be on exponential and logarithmic functions. Now, I'm not going to get into the hardcoreness of the graphs and how they're inverse functions of one another and all that fun stuff, but we will get into solving them. We will get into word problems and all that stuff. Right now, the worksheet that you picked up when you came in today, if you notice, it says week 19, week 20 worksheet. Okay, we are currently in week 19 of the year. Okay, right? So that worksheet isn't due until next week, Friday, the 27th. Okay? It also will serve as your that's all. So my plan is to test on unit 5 next week, Friday. Okay, right? So it's that short of a unit, okay? Because we're not going to go deep into all of the stuff. We're just going to pitter patter and get right at it, okay? Right? So just so you know on that, there is nothing this week, meaning no formative, no quiz, no test this week, Friday. Friday will be a learning day. Okay? Yeah. Other than that, you probably don't. I don't think you have access to your grades yet. But if you have any want or desire or need to know, you gotta know. We can talk about that. Okay. Okay. Then after exponentials and logs, then we do some sequences and series. Then we do some, actually no, I think before sequences and series we do solving systems of equations. Then we do sequences and series, and then we do conic sections. We end with conic sections. And conic sections is kind of a longer unit. It takes up most of the fourth quarter. So it is what it is. Because I make it so that if you kind of like rational function, if you do this, this, and this every single time, it should be able to. Okay. All right. Let's dive into it. Now, these first 2 slides, you don't necessarily have to write down if you don't want to. Okay. So this next one, this one right here, you don't have to write down. But I just wanted to tell you how we're going to contrast and compare. So far, we've been dealing with linear functions and rational functions, and they've been like a formula where x has been in the, if the exponent on x is a number, okay? And it changed by equal differences or, rational functions, we just did those, all that fun stuff, okay? What we're moving into now is exponential functions. Now, the variable is going to be in the exponent. That's the difference. That's what makes an exponential function an exponential function is the variable is in the exponent. Okay? And so it's changing by an equal factor. Typically it's a percentage. Like when you hear population is growing by 1.5% over the course of the last decade or so, that's an exponential growth function. It's not growing by like 1.5 people per day. It's growing by like 1.5% of the people. So the first day, if there was 1 person, next day there would be like 5. So kind of it grows, and it grows much faster. And you can see that better on a graph. So if we're talking with a linear function, the growth is always going to be the same. It's going to be a straight line, okay? And that's going to always be, you can bank on the fact that, 25 years down the road or at x equals 95, the growth is going to be the same. And so the slope of the line will always be the same. In an exponential function that's increasing by 5%, that's what the curve looks like. Notice how the curve is getting steeper and steeper and steeper and steeper. And the farther out we go, the bigger our x gets, the steeper and steeper and steeper that gets. Okay? It's growing exponentially. Okay? So we're going to utilize, did I even write these down? Okay. So what the equations look like, so this would be y equals 5x plus 100. That's the equation of the line. Okay? But over on this side, this would be y equals here 100 times 1.05 to the x power. So that variable now is in our exponent. Okay? So we're going to have two different types of equations because we're going to need two different types of equations. We're going to need an exponential equation, and we're going to need a logarithmic equation. And the reason that we need both of those types is because in order to solve one, you have to put it into the other. Okay? So if I give you an exponential equation, you're going to solve it by making it become a logarithmic equation. If I give you a logarithmic equation, you're going to solve it by making it into an exponential equation. These are inverse functions. Which we talked for about 10 minutes about first semester. Okay? Just note that inverses cancel each other out. Okay? So that's how we're able to solve. So an exponential function is going to look like y equals some number times b to the x power. Where this a value right here is going to be your starting number, and this b value here is either going to be your growth or your decay rate. If b is above 1, you're growing, because 1 is 100%. So if it's above 1, you're growing. If it's less than 1, you're decaying. You're small. Log functions are going to look like that, where you're going to have a base, And that base is going to be your growth or your decay rate. Now, natural log functions have a base of the letter E. E is called Euler's number, 2.718281189. Okay. And natural logs are actually much easier than regular logs, just so you know. But we'll get to those later on. Okay. But that would have a base of. Okay. So let's talk here a little bit about how we go back and forth between the two. This next thing that I'm going to show you, as you can clearly see because I've got 2 stars around it already, super important. You want to make like your own little section of the notes with just this so that you can always refer back to it and so that you memorize that. Okay, I'll give you a second to get this written down. So, I color-coded them for you. B is the base in your exponential form. It is the base in your logarithmic form. Okay? The exponent is the exponent. Okay? And the arg is the argument. Okay? Technically, that's a math term for what we call the argument. Okay? So logs are exponent finders. Okay? Logarithmic functions find exponent. What exponent goes on the base to get what I want to get that argument. There are 2 rules in both of these forms. Okay? The 2 rules are, first off, the argument and the base always are positive. No discussions. If you get a negative argument, so if you got log base 7 of negative 15, you can't do it. Your calculator will yell at you when you try and do it. I'll yell at you when you try and do it. Okay? Alright? Can't happen. Same thing with the base. Can't be negative. Okay? The second thing, the second rule, is that your base can't be equal to 1. Because 1 to any power is 1. So you'd have 1 to the x power equals 1. Duh. Doesn't matter what x is. Okay? Or 0. Same thing. 0 to any power is 0. Okay? So those aren't, we can't use those for bases in our exponential or logarithmic functions. Okay? So what we're going to do here now, or what we're going to practice here right now, is we're going to practice rewriting these. Okay? So again, I remind you that if you've got a base, you should have this memorized soon with an exponent that's going to equal the argument. And so what that does then, we flippity-floppity this, that becomes log with that base of the argument and that equals the exponent. Okay? Now, when I'm writing, or when you are writing logarithmics, write that base a little smaller and down by that hook of the G. You know, when you write log and you got that G hook down there, okay? write it down underneath the circular part by the hook. Okay. So this would be, if I would rewrite this one, log, how I read this, again, let's talk about how we read this. How I read this is log base 9 of 27 equals 3/2. And that's a true statement. If I put the exponent of 3/2 onto 9, my answer is 27. True statement. Okay? So if I want to rewrite this into the other form, it's in logarithmic form. I want to put it in exponential form. My base would be 9. My exponent would be 3/2. And my argument would be 27. So that's it rewritten. Log base 7 of 343 equals 3 would be what? 7 to the third power equals 343. Or 7 cubed equals 343. Log base 4 of 16 equals 2. Becomes what? Squared. Equals 16. Now the tricky one. I can see it through his face. Okay. Natural log, again, is log base e, right? Okay. So this is really that, right? We just don't write Loge, L-O-G-E, we write natural log. Okay? So this one would switch over to be e squared equals x. Okay? What I want you to do now is take them from exponential form and put them in logarithmic form. Can we get all 4 of them on there? Look at that. Okay. Look at that. Almost as if I planned it that way. So the first one I would start out with log. My base would be 7. My argument is 49, and that is equal to my exponent, which is 2. So this in logarithmic form would be log base 7 of 49 equals 2. Number 2, my base is 5. My argument is y, and my exponent is x. So it would be log base 5 of y equals x. In number 3, you want it to be log base e of 3 equals x, but log base e is natural log. So we would just write natural log of 3 equals x. And yes, Lily, I know you're thinking it. I will mark log base e wrong on any and all assessments. Because it's just not mathematically right. It's bad maths. And lastly, log base 8 of 4 equals 2/3. Okay. Look. As we progress into this chapter, we want to be able to evaluate log. So far, every one of those statements that I just gave you has been true. Okay? So if we go back to them, log base 7 of 49 is 2, because 7 squared is 49. What I mean by evaluating a log is I'm just going to give you this in the box. And I'm going to say, tell me what it is. And so then what you have to do is you have to think of how I say it is, in this case, log base 2 of 8. In my brain, what I'm saying is, what exponent needs to go on 2 to get me 8? Okay. Well, 8 is 2 times 4, right? And 4 is 2 times 2. So 8 is 2 times 2 times 2. So how many 2's do we need to get 8? 3. So this is 3. Okay. Log base 7 of 49. What exponent needs to go on 7 to get me 49? 2, right? That would be 2. Log base 5 of 125. What exponent needs to go on 5 to get me 125? No. 5 times 5 is 25, times 5 is 125. So it's 3. Right? Now, those easy ones you can do without a calculator. Okay? If you know your multiple or you know your powers of numbers. Okay? But that's not always going to be the case. Okay? So for instance, if I want to talk about log base 3 of 8, I'm still asking myself, what power goes on 3 to get me 8? Okay? Still asking that. Is it a nice, easy one, though? No, but we can kind of guess where it's going to be, right? Okay? What's it going to be in between? Why 1 and 2? Is 3 to the power 1 is 3, and 3 to the power 2 is 9, right? So it's got to be between 1 and 2. Is it closer to 1, or is it closer to 2? Closer to 2, because 8 is closer to 9. Okay? So we kind of got a range of where it's going to be. Okay? But how we actually go about doing that, and I'll tell you this, you can use this on these too, on those easy ones. It'll just come out nice and pretty. Okay? This one's going to come out a big long decimal on your calculator, and you need a calculator in order. Okay? Okay? So what we utilize is something called the change of base formula. Okay? Now, your calculators, most of your calculators are the TI-30X type calculators. Okay? Some of you have a little bit offshoots of them, but I don't think anybody's got a Casio. I think everybody in here is utilizing a TI type calculator. On scientific calculators, there should be a key that says log. Okay. On the TIs, it's over on the left-hand side, up next to the second key, typically. Okay. Side note, before I forget too, we're missing 2 of these type of calculators, just so you know. Okay? So if you still want access to them, bring them back. So that key is called the log key, obviously, but it's limited. It is the log base 10. Right below that key is the ln key, or the natural log key, and that one is for all logs base e. Okay. So, how we utilize the change of base formula is, whatever my argument is, that either one, as long as you stay consistent, it doesn't matter which formula you use, you get the same answer. So log base 3 of 8 would be log of 8 divided by log of 3. Or it would be natural log of 8 divided by natural log of 3. Now, I will tell you this. On some calculators, it is extremely crucial that you follow the steps on how to do this. So like on these TI-30Xs that are the most common ones, when I go log of 8, notice how it opens up a set of parentheses. It looks like this on the calculator when you type it in. I don't know what yours is. Does it open up a set of parentheses? Okay. Right? It is very crucial that when you type in the 8, that you then close that parentheses before you do the divide. Because otherwise what the calculator sees is it's going to take 8 and divide it by the log of 3, then take the log of that number. Okay? So log of 8 divided by log of 3 gets me 1.89278926.1. Try that on your calculator to make sure you get that now. Typically, when we evaluate logs, we're going to round them to 3 decimal places. So the answer here that I would want, let's say, on next Friday's test, would be 1.89. Later on, might be this week, or for sure next week, we're going to start solving logarithmic and exponential equations. I think we actually started tomorrow, but I think we start with exponentials tomorrow. If this were a case and you're in the middle of the problem, leave it on your calculator and do with that being said, on any scientific calculator, evaluate me those two logs. Log base 3 of 34 and log base 34 of 3. So on this one, I got 3.209831677. So we would call that 3.210. On this one, I got 0.311542816. So we would call that 0.312. Agree? Okay. That is all I got for you for today.